Okay, this is the 6.8 recording for the chemistry periodic of week 8. We have 6.1 to 6.6, we have 6.8, and we also have 7.1 to 7.4. There actually is no quiz for 6.7. It's an experiment. يعني what's it's yeah, there's no quiz for 6.7 since it's just an experiment and you don't really need to know what's happening. It's just them adding ionic solids to each other. Uh, it's not important and it probably won't come. That's why it goes 6.1, 6.8, 6. No, 6.1.6.6, then 6.8, then 7.1 to 7.4. 7, chapter 7 is very easy, but this 6.8 I want to stress on because I genuinely think the hard questions are all going to come from 6.8. ف yeah, uh, this is the 6.8 quiz. The 6.1 to 6.6 is already uploaded. If you ever like, I'm gonna fix it later. But for now, for the chemistry, like, حتى in finals, when finals comes, just what was this? Just open just my channel. Open playlists. And يعني هيك view for playlist whatever. You see يعني upload. Okay, I'll fix this later obviously. يعني once you're gonna after I upload this video, I'm gonna add all the chemistry videos here. I'll have one basically for every subject. If you wanna go back maybe in finals or something like for physics, يعني I have all the sections for physics here. If there's anything specific you need to see, just open the playlist and يعني click on the video you want. Okay, this is just way easier than going through all my videos. يعني here. ف yeah, because I already have the 6.1 to 6.6 recording in the chemistry. It's already here. Okay. المهم, let's start. Before starting, I wanna shout out سيف النومان and شو اسمه خالد السهلاوي. They شو اسمه they really help me out when it comes to recording videos and stuff. وأصلا they're the ones who helped me out start the channel كمان. ف yeah, shout out to them. Let's start. What are true about molecular solids? Okay, some can conduct electricity in water. They have low boiling points. They do not dissolve in water. They are not made up of ions. They don't have high melting points. They're not made up of ions. Okay, this is old. I think everybody knows this. Okay, my fault. Uh, I submitted the quiz. Molecular solids. I said they don't dissolve in water, but they do. They do dissolve in water. يعني for example, sugar is a molecular solid and it dissolves in water. Some molecular solids dissolve in water and others do not. Okay, my fault. Uh, yeah, so it's actually they only have low boiling points and some can conduct electricity in water. Those are the acids, if you remember. They have high melting points, of course, no. They are made up of ions, of course, no. They do not dissolve in water. They do not dissolve in water, but some of them do. Okay, يعني keep that in mind. Question 2. What are molecular solids? Sugar, if you guys know C6H12O6, it's glucose. It's a molecular solid. Molecular solids are non-metal. Okay. Sodium chloride is NaCl, which is ionic. Okay, I think everybody knows this. Wax. What's the formula for wax actually? What is the formula of wax? Okay, whatever. Yeah. That's non-metal. Non-metal. Wax is a molecular solid. HCl. HCl is a molecular solid because it's non-metal. Non-metal. All acids are molecular solids, by the way, and HCl is an acid. Dry ice. Dry ice is carbon dioxide, solid carbon dioxide, and carbon dioxide is a molecular solid. Okay, for solid CO2. Question 3. Okay, it's question 3, questions 5, and question 6. These are the scary ones. Okay, look, it's concentration of ions, except limiting and excess is back, and it's the same thing. It's the same thing as how we used to take it, limiting and excess, except يعني there's an extra step. What am I gonna do? My job is to teach you the steps. I'll write down the steps for you. Your job is to memorize it, understand it, whatever you want. But these are the steps you have to follow. In your written part, make sure to write down the steps. Okay, let me take this. Okay, and I'll add it to a new page. How do you know you're dealing with a concentration question or a limiting excess question? If you read the question, they'd say sodium chloride solution is added to lead nitrate solution, whatever. They gave you the volume, they gave you concentration, whatever, and the precipitate is formed. If the precipitate is formed, that means there's a reaction going on. Okay, so whenever you see precipitate formed, know that it's an LR/ER question. Okay, that's the thing you have to look for. If they say precipitate is formed, okay. Also, if they say the concentration of the ion is very low, right, zero, that means they're talking about the limiting, because always the concentration of the limiting is zero. Okay, what are the steps? Let's start. The first thing you have to do is you write the dissociation reaction of each one, reaction of each compound. Okay, the second step, find the moles of each compound. The third step, this is if the precipitate forms. These two steps is to find concentration. Okay, concentration. But if precipitate forms, precipitate forms, that means we're dealing with LR and ER, limiting and excess. Okay, limiting ratio and excess ratio. That's if precipitate forms. Okay, what happens if precipitate forms? We have some steps. You have to write the net ionic equation. Write the net ionic equation. If you don't know what the net ionic equation, I think in the 6.1, 6.6 recording, I explained the overall non-ionic, the overall ionic, and the net ionic equation. Okay. If you want to go back and watch that, yani, I think if you're watching this video, you already watched it. But muhim, I explained it there. So you write the net ionic equation. Okay. The second step is find your LR and ER. Find LR and ER. You guys know you do that by doing N over coefficient. Okay. The third step, you cross multiply. Actually, no, I'm not going to give you the step. After you find your LR and ER, always the concentration of the limiting one equals zero, and then the concentration of the excess ratio equals the N left, the leftover moles over V total. It's always over V total. But the special case is there are other ones, because in this case you have four. One of them is limiting. I'll tell you. CL is limiting, and one of them is excess. In this case, it's PB. This is the excess, and the rest are what we call the spectators. Right, the spectators and the spectators. To find the spectators is very easy. It's super easy. You don't need to. You don't need to stress on that. But the hard part is knowing the limiting and excess. After you know your limiting, it's zero. Okay, but to find the concentration of the excess, you need to do N left over V total. This is where some people they get tricked, they get messed up. They mess up. To find N left, it's always the moles you start with, so the N initial minus how many moles you used up. Okay, how do you find the moles used up? Obviously N initial is how much you're starting with, and you'll see. How do you find the moles you used? You always cross multiply with the limiting. Okay, so far صراحة it's not that much. This is it صراحة. Just write the dissociation reaction, find the moles of each compound. If you know that it's precipitate being formed, you need to know which one is the LR and ER. How do you know? You have to write the net ionic equation and then do N over coefficient. Okay, let's start solving. The first step. Let me take this over here, like this. The first step we said is write the dissociation reaction of each compound. Okay, the right dissociation reaction of each compound. What compounds do we have? We have sodium chloride and we have a lead nitrate. Okay, sodium chloride is NaCl. Okay, everybody knows that. But lead nitrate, this is the tricky one. Lead nitrate is PbNO3 2. Okay, why this is a tricky one? Because some of you will just put PbNO3. Okay, please don't do that. You know that lead is Pb2 plus because they said 2, and nitrate is NO3 minus. So to form a compound, you crisscross. You take this down, you take this down, you get PbNO3 2. Okay, please yani don't mess up on this. It's very it's a dumb mistake. In the exam, I think they'll give you an easier compound, but if they do, make sure you know which compound you're talking about by using the crisscross method. Okay, in the exam, inshallah, they'll give you an easier compound that's straightforward. Like NaCl is straightforward. But let's start. What is the dissociation reaction of NaCl? NaCl is a solution, so it's aqueous. Dissociate it. What does it become? Na plus and Cl minus. How about PbNO3 2? Let's put it down here. Here, PbNO3 2. It's a solution, so aqueous. Becomes Pb2 plus. If you don't know the charges, they're here, by the way. They're already given in the question. Pb2 plus, which is aqueous, and NO3 minus aqueous. Check both equations, are they balanced? First one's obviously balanced. Second one is not balanced. Pb is balanced, but NO3 you need to add 2 NO3 over here. Okay, good. Like this, so far, it's pretty easy. The second step is to find the moles of each compound. Okay, the moles of each compound. How do we do that? Let's look at the question. For NaCl, we have 5.5 milliliters and 0.5 molar concentration. So we have the volume and we have the concentration. N equals Cv. For lead nitrate, we have the volume and we have the concentration. Again, N equals Cv. So let's find the moles for sodium chloride. It's going to be N equals the concentration 0.5 times the volume. The volume has to be in dm cube. Remember, how do you change it? You divide by 1000. So it will be 0.5. 0.0055. Okay, and this is going to be here again. This has to be in dm cube, so you divide by 1000. It will become N equals the concentration 0.5 times 0.0145. Okay, for each one, what do you get? For NaCl, you're gonna get 2.75 times 10 to the negative 3. For PbNO3 2, you get 7.25 times 10 to the negative 3. Okay, so what do? We found the mole for each compound. How do you write it now? Why I like writing it and keeping a space between them, because I put the moles under each one. So 2.75 times 10 to the negative 3 moles, and this is 7.25 times 10 to the negative 3 moles. Okay, do we know how to find the moles of everything else in the reaction if you have the moles of this? Of course you can. If they're all the same coefficient, like here NaCl 1, Na plus is 1, Cl minus is 1, you just keep it as 2.75 times 10 to the negative 3 moles, and also here 2.75 times 10 to the negative 3 moles. Okay, here same coefficient, same moles, 7.25, 7.25 times 10 to the negative 3 moles. How about here? This is times 2. Why times 2? Because it's a coefficient of 2. So if you multiply it by 2, it will be شو اسمه 0.0145 on your calculator, which is 1.45 times 10 to the negative 2 moles. Okay, because you get on your calculator 0.0145. This is actually 1.45 times 10 to the negative 2. Okay, that's what you get on your calculator. I don't know, my calculator didn't give it to me in scientific notation. المهم, we finished the first 2 steps. What's the third step? If the precipitate forms, you're doing LR&ER. Okay, so far these steps are what you have to do for every concentration question. Okay, now since we said the precipitates formed, we're solving LR&ER. For what do you have to do? You have to write the net ionic equation. What's the net ionic equation? The net ionic equation is the equation that only has to do with the precipitate that is formed. In this case, the precipitate being formed is lead chloride, which is PbCl2. Why PbCl2? Because lead is Pb2 plus and Cl is Cl minus. Crisscross, you get PbCl2. Okay? Inshallah, they give you an easier one in the exam. I hope they do. I won't, I know most people get mixed up. Inshallah, they'll give you an easier compound. But PbCl2 is the hardest one, صراحة, because lead is always, you're playing with the crisscross. So, inshallah, they give you something easy. المهم, PbCl2 is our precipitate. How do you write the net ionic equation? Now we have to write the net ionic, right? The net ionic. The way our chemistry teacher taught us in writing the net ionic, and the way I taught you before, was start by drawing an arrow and put PbCl2 on the right, which is your precipitate. Okay, you see, what is PbCl2 made of? It's made up of Pb2 plus and Cl minus. Aqueous, obviously, and aqueous. Check if it's balanced. Here you have one Pb, here you have one Pb, here you have one Cl, here you have two Cl. So what do? You put two Cl minus. Okay, that's how you write the net ionic. After you write the net ionic, what's the next step? Have to find which one is limiting, which one is excess by doing n over coefficient. So let's do it. What's the moles of Pb? The moles of Pb is 7.25 times 10 to the negative 3, right? 7.25 times 10 to the negative 3. And the moles of Cl minus will be 2.75 times 10 to the negative 3. 2.75 times 10 to the negative 3. Can we do n over coefficient now to find the limiting? You do n over coefficient, right? What's the, this is to find the ratio, by the way, the ratio. This is what we call the ratio. What's the ratio of Pb2 plus? The ratio of Pb2 plus is going to be the moles of Pb over the coefficient of Pb, which is 1. How about the ratio of Cl minus? The ratio of Cl minus. It's going to be the moles of Cl, which is 2.75 times 10 to the negative 3 over the coefficient, which is 2. Which one is going to be smaller? Obviously, Pb2 plus will be bigger than Cl minus. So what will Pb be? It will be the excess. And Cl minus is the limiting. But you're not done there, okay? What you have to do after that is find the concentration. They're not asking you which one's limiting, which one's excess. They're asking you to find the concentration, okay? After you find the limiting and excess, by the way, and no, why this is excess, why this is limiting is because this is bigger. Always the bigger one is the excess, okay? With ratios. Now to find the concentration. Let's start with the concentration of the limiting. Concentration of Cl minus, which is our limiting, is 0. Why? Because limiting ratio always equals 0. How about the excess? Let's start with Pb. Let's continue with Pb. Pb2 plus. Put the charges. Equals, since it's the excess, what's the rule to find the concentration of the excess? It's the n left over V total. Okay. By the way, every concentration, the concentration of any ion is always the n over V total. But since we're speaking about excess, you have to use n left, okay? Because the excess changes moles. The moles of excess always changes. For what will be n left of Pb over V total? Uh, how do you find it? I said you cross multiply with the limiting, okay? N left is, we said n left is n initial minus the n used. What's going to be the n initial? The n initial is of Pb, of course, is how many moles? Yani how many moles of Pb do you have right now? 7.25 times 10 to the negative 3. Okay, 7.25 times 10 to the negative 3. Minus the n used up. How many moles are used up of Pb? How do you find it? You cross multiply with the limiting. For over here, you go to your net ionic. You go to your net ionic. I erase this. We have, this is our reaction ratio, right? Which is 1 and 2. That's our RR, and this is our GR. Okay? The GR of Cl is 2.75 times 10 to the negative 3. We don't know how much moles of Pb, right? So you cross multiply, you're gonna get, why did I put 1? No, no, you cross multiply, it's x moles, right, of PB. You cross multiply, I think everybody knows how to cross multiply. Okay, you get, I think 2.75 divided by 2. You get 1.375 times 10 to the negative 3. And this is going to be 7.25 times 10 to the negative 3 minus answer. Hold up. Give me a second. 7.25 times 10 to the minus 3 minus 1.375 times 10 to the minus 3. You get 5.875 times 10 to the minus 3. Okay, so what was the concentration of PB2 plus B? It's gonna be 5.875 times 10 to the minus 3 over the V total. V total, you just add up the volumes. You add up the volumes. Okay, it's gonna be 5.5, 14.5, 20 milliliters. Make it dm cube by dividing by 1,000. You get 0.02. If I divide it by 0.02, and you're gonna get, I think, you get 0.29375. They want two significant figures, but it's gonna stay 0.29 molar concentration, whatever. And Cl, we said it's 0. Okay, what's left? We still have two ions left, right? And these are the spectator ions. This is the easy part. Okay, this is the easy part. So the concentration of the spectator ions is always just the mole over V total. It's super easy. This is the easiest one. You know, because concentration C equals N over V. So the concentration of the ions will just be C equals N over V. Just you have to know what's the moles of Na. Go back to your reaction. It will be 2.75 times 10 to the negative 3 over the V total, which is 0.02. The V total doesn't change. It's always 0.02 or whatever you got, because we said 20 milliliters. Okay, you're gonna get 2.75 times 10 to the minus 3 divided by 0.02. You're gonna get 0.1375. Make it two significant figures, you get 0.14 molar concentration. Okay, how about NO3 minus? Again, N over V total. You get, what's the moles of NO3 minus? 1.45 times 10 to the negative 2, right? So 1.45 times 10 to the negative 2. Okay, over V total, which is again 0.02. You get 0.725 more, so 0.725, but you need it to be two significant figures, so it will be 0.73 molar concentration. It wouldn't be wrong to say, because like if you zoom out, yani, this is all for one question. Okay, honestly, yani, if you want me to be honest, they're not gonna get a question from this in the computer part. Like, I'm gonna be honest with you, they won't get a question from this in the computer part. I honestly think, like they did in previous years, they're gonna get it as شو اسمه, as the written part. And I actually have the question that came from the written part of a few years back. I'll get it for you, and I'll solve it with you guys now. Actually, no, I won't solve it now. I'll solve it at the end of the recording. Okay. Before moving on to question 4, I wanna show you, since every limiting exercise question I've solved in class, and every question I've looked at apart from this question 3, they always asked you, حتى in the written parts, they always ask you to calculate the mass of the excess. Calculate the mass of the excess. So to calculate the mass of excess, let's say يعني part D مثلا, calculate mass of, they won't say the excess of PB2 plus, or actually no, they'll say excess, because يعني if they say PB2 plus, it's obvious that's the excess. بس المهم, they'll say calculate the mass of whatever, they're going to be talking about the excess. How do you do it? You have to use N equals M over M. Okay, you're going to be like, well, that's easy, no? But why am I saying it? It's يعني, why am I showing you how to do it? It's because some people will use the old moles. You know, if you're talking about excess, you have to use the n left, okay? And how do you find n left? You use n initial minus n used up, which is 7.25 times 10 minus 3 minus 1.375 times 10 to the minus 3. You get 5.875 times 10 to the minus 3. Please make sure you use 5.87 times 10 to the minus 3. Okay? Don't use the odd moles. Equals the mass over the molar mass Pb2 plus. What's the molar mass of lead? What is the molar mass of lead? 207. Okay. Over 207, you cross multiply and you'll get, I don't know, whatever mass. Let me do it actually. 5.875 times 10 to the minus 3 times 207. You get 1.22 grams. Okay, please, yani, this is really, if you get all of this correct and at the end you get this wrong, it's very, yani, it's haram, you know. I feel bad. It's a stupid mistake to lose marks on. المهم, let's continue. uh, I'm telling you, they won't get this in the computer part. It hasn't come in the computer part in any year. It hasn't come in the computer part in any AMS, even though it's been in our material for the past 3 weeks. It hasn't come in a single AMS. They'll only get it in written parts. Okay, I hope so, inshallah, unless they decide to switch up. But the way it's always been is it comes in the written and they get one question. المهم, naming ionic solids, this is easy. PbSO4, lead, was always put II for lead. And then sulfate, Ag is silver and Br is bromide. Magnesium is Mg, and as Mg is magnesium and O3 is nitrate. Okay, easy questions, yani. Oh, small. Uh, question 5. I think this is another concentration question. Yeah, this one's easy though. Okay, if you remember the first and second step, the first step was always dissociation reaction, and the second step was find the moles of each one. Okay, this is the step for every concentration question. The third step of every concentration question is check if there's precipitate. Check if precipitate. Okay, precipitate. If there's a precipitate, شو اسمه, you have to do the limiting steps and the ER and the excess steps. But in this case, it's just CaCl2. They didn't say that it's mixed with anything else. They didn't say there's a precipitate. There's nothing. But what do you have to do? Two simple steps: dissociation reaction and the mass of each one. Dissociation reaction of CaCl2. CaCl2 dissociates to do Ca2 plus. This is aqueous. Ca2 plus aqueous plus Cl minus aqueous. Please, I'm not sure if you'll get marks taken off you if you don't put the state symbols, but I think you will, okay? Because I remember my chemistry teacher saying you're gonna lose marks if you don't write your state symbols. They're important to write. Please write them. And it's obvious. 90% of the time it's just aqueous, okay? Unless it's always aqueous, unless they say it's a liquid, or unless they say it's a gas, or sometimes they say, or if it's a precipitate, it's a solid. Other than that, it's always aqueous, okay? Unless they tell you it's always aqueous, unless they tell you it's liquid or gas, or akid if it's a precipitate, then it's gonna be solid. بس المهم, this is a dissociation reaction of CaCl2. Balance this. Ca is balanced. Cl2 isn't balanced. There's 2 here, so you have to put the 2 here. Okay, now we have to find the moles. What's the moles of CaCl2? Okay, the moles of Cl2 is N equals Cv, so N equals, make this dm cube, it will be 0.12 times 0.2, because you divide by 1000 to make it dm cube. Okay, so you'll get 0.024. Okay, this is the same coefficient, so 0.024. This is 2 as a coefficient, so you have to multiply 0.048, and أكيد moles, whatever. How do you find the concentration? You have to do now, the concentration of, let's say, calcium is N over V total, N over V total, okay, which is going to be the moles of calcium, 0.024 over V total, which is 0.12, and you're going to get 0.20. And how about Cl minus? It's going to be the moles of Cl minus, which is 0.048, divided by V total, which is 0.12, which is 0.40. Okay, that's it. Yani this one's way easier than the limiting excess. Okay, question 6, same thing. Okay, uh, 5.85 grams of NaCl is added to 12 milliliters of 0.2 AlCl3. Water is added until the total volume is 150. So 150 is V total. Calculate the concentration of ions given that both compounds are completely soluble in water and no reaction takes place between them. Okay? No reaction. No reaction, yani there's no precipitate formed. So you're not doing, it's not LR and ER. You're not doing limiting and excess. Okay, since there's no reaction. Okay, so since we're not doing limiting excess, two steps: dissociation reaction, okay, and finding moles. Find the N. Okay, what's the dissociation reaction of each one? Let's start with NaCl. NaCl is we're starting with solutions, right? So aqueous. Actually, no, I think yeah, aqueous. Okay, to produce Na plus aqueous and Cl minus aqueous. How about AlCl3? AlCl3, AlCl3 aqueous, because it's at solution, produced Al3 plus aqueous plus Cl minus aqueous. Is this balanced? Al is balanced, but this is 3Cl, so you have to put the 3 over here. Okay, we did the dissociation reaction. Now we have to find N. How do you find the moles of NaCl? Let's look at what they have given. They have 5.85 grams of NaCl. Okay, how do you find moles? It's N equals M over M. If you have mass, right? In this case, our mass is 5.85, and the molar mass of NaCl is 58.5. It's given. You should get 0.1, I think. 5.85 divided by 58.5. Yeah, it's 0.1. So you put 0.1 moles, 0.1 moles, and 0.1 mole. How about AlCl3? We have volume and we have concentration given. So you have to use N equals Cv. So what will it be? N equals the concentration 0.2 times 0.012, because you have to make this into dm cubed. So you divide by 1,000. Okay, and you should get 0.2 times 0.012, 2.4 times 10 to the negative 3. 2.4 times 10 to the negative 3. 2.4 times 10 to the negative 3. Same coefficient, so 2.4 times 10 to the negative 3. And this one has 3 as the coefficient, so you have to multiply by 3. And it's going to be 7.2 times 10 to the negative 3. Obviously, moles, moles, and moles. Okay. Now, after that, can we find the concentration for everything? Yes, we can. So let's start with the concentration of aluminium or aluminum. The concentration of Al3 plus will be the moles of Al3 over V total, right? What's the moles N total? It's always N total, by the way. The moles of Al3 plus are 2.4 times 10 to the negative 3 over what's V total? V total is 150 milliliters. So it's going to be 0.15 dm cube because you divide by 1,000. Okay, so over 0.15, and you will get 0.016. 0.016. How about sodium? Let's continue with sodium. The concentration of Na plus should be N of N total over V total. Okay, because you know always C equals N over V. What's the concentration? What's the moles of sodium? We have 0.1 over V total, which is 0.15. You get 0.6666, whatever. So you put it as 0.67. Okay. How about I'll put it over here. The concentration of Cl minus. The concentration of Cl minus equals the N total over V total. What's the moles of chlorine? Here's the thing. You have 0.1 over here, and you have 7.2 times 10 to the negative 3 over here. Okay, what you have to do, you have to add them up, because we're saying N total. But you have to add up the total moles. You have to get the total moles. That will be 0.1 plus 7.2 times 10 to the negative 3 over, this is plus, over 0.15. Okay, that yani you have to make sure you add them up, and you get 0.71. Okay, please put it in your calculator like this as a fraction. Huh? You get 0.71. That's it. Yani there's no more concentration questions. The rest of the quiz is easy. صراحة. What's the formula of calcium carbonate? Calcium is Ca plus, no, it's Ca2 plus, and the carbonate is CO3 2 minus. Same charge, they cancel, so it will just be CaCO3. Iron chloride will be Fe2 plus, Cl is Cl minus, crisscross, you get FeCl2 because the 2 goes down. Okay, how about magnesium bromide? Oh, magnesium bromide. Magnesium is Mg2 plus, and bromide is group 7, so it's Br minus. This is all from a periodic table, huh? Crisscross, you get MgBr2, sorry. please, yani, if you don't know how to get the charges from the periodic table by now, that's a big problem, to be honest. Make sure you do. If it's group 7, remember it needs 1 electron, so it's minus. If it's group 6, it's 2 minus. If it's group 5, it's 3 minus. We skip group 4. Group 3 is 3 plus. Group 2 is 2 plus, and group 1 is just plus. Okay. What are true about ionic solids? They have high melting points, they have high boiling points, they conduct electricity when molten, but are they made up of molecules? No, they're not. Okay. Question 8. K is okay. See, Anna, if you look at the answer I put potassium, hydrogen, calcium, ammonium. I got it wrong. Okay, you have to put potassium ion, hydrogen ion, calcium ion, ammonium ion. Okay, because K is potassium, potassium ion. H is hydrogen ion. Ca is calcium ion. NH4 is ammonium ion. Please don't put ammonia. Okay, ammonia is different. Ammonia is NH3. Ammonium is NH4. Okay, and some people they would put it. And also question 9, same concept. And I put chlorine. It's supposed to be chlorine ion, hydroxide ion, SO4 sulfate ion, nitrate ion. Okay, you have to put ion. Okay. Yani that's all they're easy. Question 10. How many questions? 11 questions. طيب. Sodium iodide is a salt that can be mixed with sodium chloride to produce iodized table salt. Okay, sodium iodide is NaI. Okay, metal, non-metal. So it's gonna be ionic, right? Usually everything sodium bonds with is usually ionic compound. Okay, put that in your head. The structure of sodium iodide is a lattice structure. Why lattice? Because it's ionic. Ionic compounds always have a crystal lattice structure. This is, yani, it's over here. Not wait, just wait for it to load. Uh, Over here. This is the lattice structure. Okay, the structure of ionic solids. Where did they say it? This is the, I don't know where this lattice. Yeah, here lattice. You see lattice? It's always a lattice structure for any ionic compound. It's composed of oppositely charged ions, and I remember I told you it's always opposite. Okay, if this is like here it's positive, here's negative, 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 negative. I explained this in my AMS quiz, I think, or the previous quiz, but it's always surrounded by oppositely charged ions. Like look here, this negative ion is surrounded by positive, 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 and positive always, and it's always surrounded by 6. Okay, always 6, always surrounded by 6. It's here, I think, 6 oppositely charged ions. 6. Like look here, this blue one in the middle. 1, 2, 3, 4, 5, 6. Okay, obviously this one won't show because there's one more to the right, but and they won't show. This is zoomed in. It's a zoomed in diagram, but it's always surrounded by, always or always always المهم, always it's always surrounded by 6 oppositely charged ions. Okay, it's not here, but yani obviously oppositely charged, but maybe they ask you how much, say 6. What's the type of bonding? Obviously ionic bonding. Question 11. Crisscross. These same charges cancel. MgO. Crisscross. Same charges cancel. NH4Cl. Take this 2 down. Take this 3 down. Ca3 and 2. The last one. Al3SO4 2 minus. Take this down. Take this down. You have to keep the 3 outside. SO4 3. Yeah. Uh, that's it. Now I'm gonna do the one that came uh in the written part last time. Let me find it was uh okay. For this I got this, my friend sent me, Jamil, if you're watching, thank you. This is a past paper from 2020. This is 2024, 2022. Grade 10 had it. um So a solution is formed. A solution is formed by mixing 100 milliliters of 0.2 molar BaCl2 and 100 milliliters 0.1 FeT2SO4. Calculate the mass of BaSO4 that will form, assuming complete precipitation. Okay. أول شيء they're saying complete precipitation, فyou have to know we're looking at LR and ER. What's the steps to solve? Let's start. Okay. The first step is previous. You start with the dissociation reaction of each compound, right? Write the dissociation reaction of each compound. Let's start. We have BaCl2 I'm actually gonna, can I, uh, wait, let me try doing this. Okay. Oh, wait. Okay. I think, yeah, because I want space to solve. Let's start with the dissociation reaction of BaCl2. You put BaCl2, dissociates to put barium is group Lena Crypsis. I think it's, what group is barium? Group 2. Okay, it's Ba2 plus aqueous, and this is شو اسمه uh, aqueous plus Cl minus aqueous. Okay, check if it's balanced. You have to put 2 for Cl to balance it. Okay, and how about the dissociation reaction of Fe2SO43? Is going to be Fe. Oh, this is a hard compound. Okay, I hope they don't give us a compound like this. Aqueous, okay, is going to be Fe 2 plus plus SO4 2 minus. Let's balance it. Fe has 2 here. Here it's 1, so just put 2. Here there's 3 SO4s. Here there's 1, so put a 3. Okay. Uh, like this we balanced it. What's the second step? شو اسمه? We have to find the moles of each compound, right? Uh, how do we do that? We do N equals CV, right? For if here it's 0 0.1, since you make it dm cubed times 0 0.2, you're gonna get 0.02 for 0.02, same coefficient for 0.02. This one you keep, you multiply by 4 for by 2, you multiply by 2, you get 0.04. Here it's gonna be 0.1 times 0.1, which is 0.01 for 0.01. Here you multiply by 2, 0.02, multiply by 3, 0.03. Okay, المهم, we got the modes. The third step, since now we know it's limiting and excess, you have to write the net ionic equation, right? The net ionic equation, you take the precipitate, which is BaSO4, right? BaSO4, because yani that's the precipitate. BaSO4. You draw an arrow, and this is obviously solid. Okay, Ba2 plus and SO4 2 minus. Okay, is it balanced? Yes, it is. Okay, طيب, you have to now find the limiting and excess. How do we do it? We have to use the ratios, right? The ratio of Ba2 plus and the ratio of, put it actually beside it, Ahsan, and the ratio of SO4 2 minus. Ba2 plus is the moles, it's N over coefficient, right? We have to use N over coefficient. So it will be the moles of Ba, which is 0.02 over the coefficient, which is 1, and SO4 2 minus, the moles of SO4 2 minus, which is 0.03 over the coefficient over here, which is 1. Which is bigger, SO4 2 minus, Ba 2 plus is the limiting, and SO4 2 minus is excess. Okay, طيب, نحن we have this equation Ba2 plus SO4 2 minus BaSO4. I'll put it down here, Ba2 plus SO4 2 minus. Don't forget to put aqueous, yeah? Aqueous to produce BaSO4, which is a solid. Okay, how do you think you can find the mass of this if you have the moles of barium? We know that the moles of barium is 0.02, right? 0.02. So can you find the mass of BaSO4? Yes, you can. Okay, you have to use RR and GR, right? Type. Let's use RR and GR. Here you have 1 mole, because let's do RR and GR. Here you have 1 mole of Ba, and we have GR is 0.02. We want the mass. What's the mass of BaSO4? BaSO4 is you get it from the periodic table, but it's 233. Okay, 233. You get it from the periodic table. It's gonna be 233, and down we put x. You cross multiply, you're gonna get 0.02 times 233, and that's 4.66. So the mass of BaSO4 equals 4.66 grams. Let me take a look at the answer. That's wrong. Yeah, he got 2.33 because he used 0.01 times 233. I don't know why. Honestly, I don't know why. What this guy's doing. Uh, but yeah, he did the dissociation reactions. This is an old paper. He did not. Yeah, limiting is SO4. It's not SO4. He did it wrong. Fa exactly. Our way is correct. 4.66. Even if you do get the wrong numbers, you get marks for just writing steps. If you write steps, you get marks. Okay. That's what I like about chemistry. They give you marks for anything. Okay. Uh, that's for part A. Now part B. Let me take it again. Calculate the concentration of all ions remaining in the solution. Wait. Yeah. Part B, calculate the concentration of all ions remaining in the solution once precipitation stops. But we need to find the concentration of everything. Let's start with the concentration of the limiting. The limiting is Ba2 plus. فأكيد is going to be 0. How about the excess? Let's continue with the excess. SO4 2 minus. You know the concentration of the excess is N left over V total, right? Over V total. What's the moles left? We have to see N initial minus the N used. Okay, how do you find the N used? You have to cross multiply with the limiting. But let's go back to our net ionic. Our limiting is 1, 0.02. SO4 is 1. فأكيد here is going to be also 0.02. The used up is going to be 0.02. How much did we start with? 0.03. Why? Because over here, 0.03 minus 0.02 gets 0.01. Okay, over V total. What's the total volume? 100 milliliters, 100 milliliters, 200 milliliters. Make it dm cube. You divide by 1000, right? Divide by 1000, you get 0.2 dm cube. Okay, so 0.01 divided by 0.2, well, 0.01 divided by 0.2, it's 0.05 mole, molar concentration. Let's continue. What we have left, we have Cl minus. Since these are the spectator ions, Cl minus and Fe, they're way easier. If we just take the moles, 0.04 over 0.2, because that's the V total, and you should get 0.04 divided by 0.2, you get 0.2 molar concentration. Please don't forget the unit. How about Fe2 plus? It's gonna be the moles of Fe2 plus, which is 0.02 divided by 0.2. You should get 0.1. Yes, you do. So you get 0.1 more. Like this, I think we're done everything that has to do with concentrations. This is I gave you uh, an extra question that came in the written in case you want to solve practice. If you want to really solve, go to the notes. There's so many questions. Like see uh, and of each solution, concentration of each ion, whatever. Like here, there's a lot of limiting, by the way, limiting questions, and the answers are all there, by the way. Okay, the answers are all there. If you want to really practice, go over the notes if you have extra time. Notes for chemistry are very, very important. Good luck. Also, if you want to read the book, uh, there's no problem in doing so. But I really, really, really advise you to do the notes and the course revision, but the notes first, okay? And I remember people asking me that the notes doesn't have answers. I mean, the answers are right here. I don't know for the CQDs, yani. The answers are here. I don't know, maybe you guys are looking at the different notes, but this is the one I have. حتى the top question, I remember this came actually in term 1 in the written. المهم, good luck. I'll post the 7.1, 7.4 later. Okay. Thank you for watching and bye. Good luck.